Hello everybody and welcome to the ML Moore channel. I'm Michael Moore. I will be your host for this tutorial. Hopefully I can help break down and make some sense of the decimal to binary conversion that's used when we talk about IP addresses. Now there's a simple way to do this with a calculator, of course, but understanding how it's done really helps get your mind around what we're looking at here. This is kind of a for beginners tutorial. I say that because I'm a computer and information science student myself. So I'm trying to pass on some of what I'm learning and hopefully to help me retain it, a little better as well. So here we go. Decimal to binary conversion, understanding using IP address examples. Okay, understanding the terminology. This may seem like a lot to start with, but we'll go through and make sense of all of this as we go. It's just kind of a primer. Decimal number IP address, such as 192.0.0.7. This is an IPv4 address. This is probably the IP address most people are used to seeing versus the IPv6. An octet. An octet is a group of 8. We use groups of 8 bits to form an IPv4 address. A bit is a binary digit. It can be a 1 or a 0. I like to think of this as a switch, which is 1 is on, 0 is off. That'll make more sense as we move through as well. IPv4 is the 4th version of IP, or Internet Protocol addresses. IPv4 IP address is 32 bits in length. It's 4 groups of 8 bits, or 4 octets. For instance, our 192.0.0.7 IP address is 4 groups of 8 bits. There's 8 bits that make up the 192, the 0, the 0, and the 7. Now given the zeros would be just 8 zeros because they're all off. A 192 would be 11000000. Once again, this will all make sense as we work through this. This is a lot of information to start off with. Breaking it down, understanding binary, starting at the end goal and working backwards. So we're going to start with binary and work towards the decimal numbers. It may seem contrary to what we're trying to do, but it'll all make sense in the end. A binary octet looks like this: 11000000, as we mentioned earlier. The values of each place in this is 128, 64, 32, 16, 8, 4, 2, 1. And that's going from left to right in our binary octet. So the first 1 in our binary octet represents 128. The second 1 in our binary octet represents 64. The rest of the zeros represent the rest of the numbers in this line, but since they're zeros, that means they're turned off, so we're not using them. The equation for this binary example is 128, because the first number of our octet is 1, so we're using the 128, plus 64, because the second number of our octet is 1, we're using the 64, equals 192, because the first and second bit is on in our binary number. The rest are off, so we don't use any of the other numbers. An easier way to see it, from me anyway, hopefully this will work for you as well. Decimal number 192 in binary, which is the one we've just covered, 11000000. Make a cheat sheet that multiplies by 2 starting at the number 1. So 1, and then 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, and so on. The results of each one of these is what we're interested in. Now reverse the order of those numbers. What I like to do is take a piece of paper and write them out across the top of that sheet of paper in the order of 128, 64, 32, 16, and so on. That way you can list your binary number below it and then use that to come up with your calculation. What we have here is the 128, the binary number 1 below it, so we use 128 in the formula. On the cheat sheet, the number 64, below that we have the binary number 1, so that's turned on. So in the formula, we use it. The rest of the numbers, if you notice, there's a 0. We don't use them. 128 plus 64 is 192. So that's how we came up with our 192. The maximum number for an octet of 8 bits is 255. You'll see this in which this is a topic for a new video, but in subnet masks. A common subnet mask may be something like 255, 255, 255, 0. As an example, what we're showing here in our cheat sheet, our binary number is all ones, 8 ones. So that means all the bits are on. So our formula is we add each one of the numbers from the cheat sheet for a total of 255. That's our maximum number that we can achieve with an 8-bit binary number. Now we're going to put it all together. Hopefully this is where it'll all make sense if we hadn't already touched the topic yet. Here's an example of the entire process to convert an IPv4 address to binary. So we're going to use the example 192.168.1.7. We have our cheat sheet, and this will show a little bit about why having that cheat sheet comes in handy. Until once you get these numbers in your head, it's a little easier to work with. You can actually go back and forth using this same cheat sheet. You can go from decimal to binary, from binary to decimal. All right, for our first number, 192. Okay, 128 is smaller than 192, so we use a 1. Now our remainder is 64. So in the 64 column, we put a 1. Those total 192, so the rest of our digits will be zeros. So 1100, 0000, and binary equals 192. For our 168, let's bring in a calculator here. We don't want programmer. Let's just do standard. So for 168, 128 is smaller than 168, so we take 128 away from that. We have 40 left. Okay, since 64 is bigger than 40, we put a 0 in that column. 32 is smaller than 40, so we put a 1. Knock 32 off of that. We're left with 8. 8 smaller than 16, so we have a 0. Here's our 8, so we put a 1 in that column. And the rest are zeros, because once we knock that 8 off, we have 0. The 1, all zeros, because of course 1 is smaller than all of these numbers. And here's our 1. So 0, 0, 0, 0, 0, 0, 1 would be our binary for 1. For our 7, 128 is larger, 64, 32, 16, and 8 are all larger, so those are all zeros. 4 is the first number that's smaller than 7. Take off 4. We have 3 left. We put a 1 in this column. 2, we put a 1 in this column. Take off 2. We're left with 1. 1 in this column. Take off 1. Now we're down to 0. So you can see how you could use that to go back and forth to create. You can use this cheat sheet to create the binary number, or use this cheat sheet to break down the binary number. In that case, it would be, we have a 1 here, so that's 128, plus we have a 1 here, 64, equals 192. This instance, 168 here, if we only had the binary number, we could say 128 plus 32 plus 8 is 168. So hopefully that helps make sense of it all. I thank you for watching. Please subscribe for more videos like this one in the future. Drop any questions or comments in the comment section below, and I'll do my best to answer them. If you've got any ideas of any topics you would like to see me cover, if it's something I know something about, I'll create a video on it and do my best to explain it from a beginner's point of view. Last but not least, if you would click those like and subscribe buttons, it greatly helps the channel. I appreciate you watching. Thanks again.